In this video, we're going to use U substitution for equations that are in quadratic form. Okay, so they're not quadratic. Remember, quadratic means it has an x squared term, but they're in the form of a quadratic. Alright, let's start off with a simple example. In fact, U substitution could probably be avoided in an example like this, but it will demonstrate exactly, the process and I think how to make this easier. So first off, what if we didn't use U substitution? This could be factored, right? I'm splitting up this x to the fourth into x squared and x squared, and then I'm going to split this plus 4. I need two numbers multiplied to 4, add a negative 5. Well, that would be negative 4 and negative 1. To double check, right, we have negative 4x squared and negative x squared, and that gives us negative 5x squared, exactly what we're looking for in that middle term. So using that zero product property, we then set each of these factors equal to 0. X squared minus 4 equals 0. X squared minus 1 equals 0. And solving this, then we add 4. X squared is 4. Over here we'd add 1. X squared is 1. And doing the square root on both sides. Right, clear the square, we could square root. We know x is, remember, anytime you do a square root of an equation, we need plus minus, so plus or minus 2 and plus or minus 1. We have 4 solutions. We have 1 and 2, and then we also have their opposites, negative 1 and 2. Alright, well, we're not used to factoring, a function, a quartic, which has a fourth power. However, you can factor it much the same. Let's look at using U substitution, though, as this will be beneficial as the problems get more complex. So the idea is we're trying to let U be this middle term here. We're going to say U is x squared. Okay. Well, if U is x squared, then I know that U squared, right, square on both sides, is x to the fourth. So therefore, I could plug this in, right? U squared is x to the fourth, and then I'm going to plug in U for my x squared here. And now this is a quadratic. Now remember, U is x squared, but as it appears right now, it is a quadratic. And if I factored U minus 4, U minus 1, just as above, I want to do the same example to point out what's going on. Set each piece equal to 0. Therefore, U is 4 or U is 1. But the original problem, right, it didn't have U, it had x. So we need to go back in and plug in x squared for U, because that was a substitution we made just to make this problem easier for a second. Right? Well, now we're back to the example above, and again, why would we do this? Because some of these problems get pretty complex, and using this idea of U substitution can make it a lot easier. Let's check out another example. Say we had x minus x to the 1/2 minus 6 equals 0. Alright. One thing to remember is x to the 1/2 simply means square root of x. Right? Sometimes it's easier to write it in rational form with a x to the 1/2 power rather than this radical, but in either case, negligible right now. Again, we're going to let U be this middle guy here. So we're going to let u equal x to the 1/2. Well, then what would u squared be? Well, if I square both sides, x to the 1/2 squared, right? Radical x squared is simply x. Now I could take this, I'm going to plug in my u's, right? U squared is x to the 1/2 is u. Again, now it's in quadratic form, much simpler to solve. In fact, this can be factored, u and u. Multiply to -6, add to -1, that'd be -3 and a +2. Setting each piece equal to 0, right, and therefore u equals 3, u equals -2. But we're not done. Remember, the problem was an x, not a u. We're not solving for u. We need x. So go back in, plug in, right, x to the 1/2 is u. So x to the 1/2 is 3, or -2. We could square both sides if it's easier for you. You could, rewrite it like this. Either way, it really doesn't matter. Okay, so squaring both sides, we have x is 9. And notice this one, like if I squared it, yeah, I would come up with x is 4. If you go and check that, though, it's not going to work. And I mean, there's a problem here, right? I can't get a radical to be a negative. I could now have a negative in the radical to get an I, but I cannot take the square root of any number to get -2. Alright, to verify that, let's quickly do a check. So if x is 9, in the original equation I have 9 minus x to the 1/2, so I'm going to rewrite it like that, right? X to the 1/2 means square root. -6 equals 0, so is that true? We'll have 9 minus 3 minus 6 equals 0. This does in fact check out. Oh. And plug in 4. 4 minus square root of 4 minus 6 equals 0. Is that true? I'd have 4 minus 2 minus 6 equals 0. And that doesn't work out, right? That's -4 equals 0. No. So this solution here, we call it extraneous. Like if we weren't careful with our algebra, we could in fact get a solution, but it doesn't work. Alright, another example. How about these negative exponents? I'm going to use the same coefficients just to keep this simple. Alright, again, try letting u be that middle term. Then therefore, what is u squared? Well, if I square this, I'd have x to the -2, which is exactly what we want, right? Here's u squared. So u squared minus u minus 6 equals 0. And again, we factor, it factors the same as before. I purposely did that to keep things simple. Again, set each piece equal to 0. U equals 3, u equals -2. Put our value of u back in, x to the -1. Right, that's what u represented. So you can see it's just a way, like we're changing the variable really quick just to make it easier on us, and then solving from there. Well, x to the -1 simply means 1 over x. Remember, negative exponent brings it to the denominator. And if we finish solving this, we can multiply both sides by this x to clear it. We'd have 1 equals 3x. Multiply both sides by x, 1 equals -2x. And last divide, x is 1/3, x is negative 1/2. I'm not going to check this, but you could. Okay, it's always a good idea to check your work and make sure the solutions do in fact work, and in this case they will. Alright, one last example. We're not going to finish it all the way through, but I do want to point out, that these guys can get pretty nasty, in which use substitution becomes more and more beneficial. So, just as before, right? What should you be? You should be this middle guy here. So if u is x squared minus 2x, then u squared would come out to that guy. Right? X squared minus 2x squared. We'll point out for these, you could expand this, right? You could expand x squared minus 2x, FOIL it out, combine like terms. More likely it will factor or use the quadratic, but check out how much work this would save us. This simply becomes u squared minus u minus 6 equals 0, and we would finish solving it as before, and remember at the end to plug back in x. Right? This equation is so much prettier and easier to work with than what we started initially. Okay, I hope that clears it up. Use substitution.